Ciao, I'm Isabella RAFFI, and I've been a calcareous nanofossil paleontologist for more than 45 years. It was 1977 when I took the Italian degree in geological sciences, discussing a thesis on the calcareous nanofossil biostratigraphy in the late Miocene, obtained in sediments from deep sea Western Atlantic. After that, I started an academic career at the University of Parma as a researcher and worked on Cenozoic, deep sea, and on-land marine succession, studying specifically nanofossil assemblages in the late Neogene sediments, mostly from the Italian area of the Mediterranean region. Later on, my scientific horizon widened in 1991 when I first participated to an ODP ocean drilling program drilling expedition. The ocean drilling program, as we all know, is the most important international program in geological sciences. And this first cruise was ODP leg 138 that drilled in the Eastern Equatorial Pacific. I repeated this experience through the years. So as a nanofossil paleontologist and biostratigrapher, I sailed over 5 times in a drilling expedition that drilled in the Equatorial Atlantic, North Atlantic, Equatorial Pacific, South Atlantic, and in 2020 in the Southern Ocean. Meanwhile, I was also invited to be a co-chief scientist in IODP Expedition 321 in the Eastern Equatorial Pacific. My research on nanofossils is mostly based on stratigraphy and chronology. I have an interest on the whole Neogene sequences and also the Paleogene successions. I studied sediments from the Mediterranean and the open ocean areas with biostratigraphic and biochronologic purpose. As far as the Mediterranean, this study resulted in proposal of regional Mediterranean biozonation for the Pliocene-Pleistocene interval and for the late Miocene interval. My research on open ocean sediments was carried out in mid and low latitude. Many of the sections that I studied were those that were recovered during the ODP expedition I sailed on. Some of these sections became reference sections that have been used for generating record of paleoclimatic proxies. So I had the opportunity to compare and correlate my nanofossil data with those reference records. During the 90s, I further developed the nanofossil biochronology for the Neogene. The nanofossil biohorizon have been placed into a temporal frame, or better, a combined chronologic frame of magnetostratigraphy and astrocyclostratigraphy. In marine sediments from mid and low latitudes, the Neogene nanofossil biochronology is actually exclusively based on astrocyclostratigraphy. That is, the individual biohorizon have been directly calibrated to the cycles that are observed in the sediment stratigraphy or in the isotope records and tuned to astronomical targets. I synthesize this nanofossil astrobiochronology over the past 25 million years in a robust biochronological framework that included correlation among Neogene open ocean and Mediterranean sections. Following this experience with the Swedish colleague and Italian colleagues, I was involved in the proposal of two biozonations that were published in 2012 and 2014, and that were referred to the Cenozoic. One was for the Neogene Quaternary interval, the other was for the Paleogene interval. Both schemes were aimed to provide a sort of revision of the Martinez and Bakri's biozonation that represented it, and that actually are really the standard for the nanofossil biostratigraphic classification. Our review of the biostratigraphies included improvement made during 4 decades, and had a special focus on assessing the reliability and the applicability of individual biobasins. Besides this prevailing interest on biostratigraphy and chronology, part of my research focused also on studying the biotic response by nanofossils to critical environmental transition as the Paleocene-Eocene thermal maximum. And this has been possible because of my experience on ODP expedition that recovered intact and complete course of this critical transition that then became a reference section for these transient intervals. To conclude, I think that my work and research played a part in assessing the importance and the power of nanofossils as biostratigraphic and biochronologic tools, and in assessing their fundamental role in the construction of the geological timescale. As such, they are successfully applied to generate age models in Cenozoic marine succession when magnetostratigraphy is lacking. They are useful in establishing age tie points and providing guidance for identification of cycles or magnetic polarity intervals. In this way, calcareous nanofossils represent a well-acknowledged tool by which the geological evidence for environmental change can be put into a precise temporal framework. Therefore, they are so useful for addressing climate and environmental objectives. Thank you.